Just as a reminder, the way that you get your attendance is you join the Zoom. I take attendance at the beginning and the end of Zoom. If you're not on it, I do mark you absent. Okay, so for you guys going on Monday, I do mark you absent. And then the next day, if you finish your assignment, I'll reconcile that attendance. Okay. So if you're not on Zoom and you get marked absent, sometime during the next day, like this morning, I had bus duty, just to let y'all know. So I haven't done anything this morning because that's what I had to do. So by the end of third period, your attendance should be reconciled if you're absent because that's my planning period. So it will take like a couple hours, obviously, but I don't want to take attendance 40 times throughout the day. So I'm not going to keep changing it every time somebody turns in an assignment. So the best thing you can do is just go ahead and be on the Zoom and get your attendance out of the way, and then you can do your assignment whenever. But again, I will reconcile that. You just got to give me time to do it. It won't be done the same day. Okay, there's no way that I can do it the same day because, like I said, third period is when I grade everything, and then I teach during fourth period, and then we coach, whatever. After school, I don't do any of that. I don't take my work home. I got to breathe at some point. So if you're turning in your assignment at 4 or 5 at night, even 3 in the afternoon, I don't reconcile attendance unless it's third period. So if it's not done until after third period. All right. So don't stress out about that. If you get an absence, if they get that phone call, that's when you guys start freaking out. So when the school sends that phone call, that's okay. Just remind your parents you get till midnight to do the assignment and then it'll reconcile. So just keep up with that. And again, I haven't done it yet, but I will. And I'll probably do y'all's right after I finish teaching so that I can make sure it's done quickly. All right. So again, don't stress out. If y'all have any questions about that, let me know. All right. Don't worry about the top. We're just going to go right here. And it says sketch the restricted function and save the domain and range. So what we're doing is before we were graphing the function all the way across the graph left to right. So now we're doing what's called domain restriction graphing, where it says only graph it on the left or only graph it on the right or only graph a specific point. Okay. So that's exactly what we're doing today. I told the students sitting in here, they need a highlighter. It'd be nice if you had a different color. Highlighter is nice. And that's how we're going to show our domain. Okay, that's where we're restricted at. So what this is leading into is piecewise functions. So I think it's on Monday. Yeah, on Monday we're doing piecewise functions. So you may need 2 or 3 colors. Okay, you may need a couple. I just use one, but you may want more. All right. So what we're doing is here's the domain restriction right here. It says graph f of x if x is greater than or equal to 0. So this tells you a couple things, and we'll get to that in a minute, but this is exactly where you're graphing your domain, okay, or your whole graph. So they take this number right here, and they plug it into the function. So this says take your function, -2, instead of x, we're going to plug in 0, plus 3. I am beyond frustrated with this. Guys, just a reminder, we start at 8:40, 8:40. Right? I even talked for a good 5 minutes. We need to be on time. When we plug this in, we get 0 plus 3 or 3. This coordinate is your boundary point. And I'll explain what that is in just a minute. Okay. Do you have to do that every time? No, you do not. Okay. You do not have to do that every time. Does it do it on the homework? I mean, on the notes, it does every time. All right. So every time I plug in, that's what I'm plugging in. It's boundary point. All right. So then this tells you 2 things. The first thing it tells you is which side to graph on. If it's greater than 0, we're looking at the x-axis. Is that the left or the right? It's the right. So this is telling us on the right. Any greater than is to the right. Okay. Any less than is to the left. The second thing it's telling us, is it included or not? So when we do our domain and it's included, we have a bracket. When it's excluded, we have parentheses. So when I talk about included and excluded, does it count towards the graph? Okay. So the way we show whether it's included or excluded are the open circle or the closed circle. So this one, because it has an equal to, it is a closed circle. So what I'm going to do is I'm going to go up to the top and review this for just a second. So if it is greater than or equal to, we're going to graph to the right. Less than or equal to, we're going to graph to the left. So that's the first thing it told you. The second thing it tells you is if it's less than or equal to or greater than or equal to, it's a closed point. What that means is you actually make a point. If it's less than or greater than, so no equal mark underneath, it's an open point, which just is a circle. That's it. And I over exaggerate my circle so you guys will be able to see that they're not closed in. Okay. All right, so this is how I start. The first thing I do is I graph. When I start graphing is I graph my boundary line. My boundary line is at 0. On this one, it happens to be the y-axis. Okay, so there's my boundary line. That's all I need my highlighter for right now. Okay. On the boundary line, you're going to put the boundary point. What do we know about the boundary point? Is it open or is it closed? It's open. I mean, it's closed. So our point is at 0, 1, 2, 3. And again, I over exaggerate it and I make you see that it is closed. Okay. The next thing I need to do is finish graphing. Okay, finish graphing. How do I finish graphing this? We have a slope of -2. So what does that mean? Down 2 and over 1. And which side can I graph on? I can only graph on the right side. You don't have to highlight, I'm just showing you. That's what it tells you. So I'm going to go down 2 and over 1. So what we did was restrict this graph to the right side of x equals 0. All right. We're going to do the same thing on the next one. You know how to graph. You can use your calculator to graph. You can use your calculator to get the points to graph. You have to graph by hand. Okay, you have to graph by hand. So if we look at this one, right here, it said that our boundary is on 4. So I'm going to graph that. What does this little symbol tell us? It's less than. So is it right or left? Left because it's less than. And the second thing it tells us is whether it's open or closed. Is it open or closed? Why is it open? It is not equal to. Very good. All of you. Great job. I don't ever do the boundary point. I'm gonna do it a couple times for you guys, but then I'm gonna show you how to do it on how to get all your points on your calculator, okay? So we're gonna plug 4 in. It's 4 minus 3 squared minus 4. 4 minus 3 is 1. Squared is 1. Minus 4 is -3. That means my boundary point is, I plugged in 4 and got -3. Is that boundary point open or closed? What do we say? Open. So I'm going to go to 4 and -3, and I'm going to open it. Now the last one was easy because it was linear, so we could just do rise over run, and that's fine. But quadratic is not as easy to graph, and I don't want you to spend 20 years plugging in points. I can't justify making you do that, okay? So what we're going to do is in our calculator, we're going to put in our function. If you guys need calculators, you can grab them. And I'll give you a second. If you have calculators at home, it'd be smart to grab them. Just make sure when you guys finish with those calculators, they go in that clear box. I just need to clean them. So again, we're going to go to y equals and we're going to put that function in. And then I'm going to go to my table. So that's second graph. So second graph. And my table is ridiculous right now. So I'm going to go back down to where it's a little bit different. I'm going to start at my boundary point, which was 4, -3. And which way do I go to graph? What did it tell me? Left. Tell me an x value to the left of this yellow line. +3. So look at +3. What's your coordinate? +3, -4. And I just graphed it. But you do need to graph these by hand, okay? The next one to the left is 2, -3. Can you guys see that you have a minimum? Once you find that vertex, I don't care if you don't really graph any more perfect points. I might graph one more up here. Like I'm going to look at 0 is 5. Just so that I can see. Remember, make it U-shaped, and then it's going to come up here. Give me 1 point at least past the vertex, okay? So find that vertex, and then give me 1 point past that. I did 2. I skipped 1, whatever, 1, 0. I came close to going through it. All right, and that's it. That's domain restriction. Draw that line and graph either on the left or the right. Watch that boundary point being open or closed. All right. When we finish these 4, we'll go back and talk about domain and range because I know at the top it said find the domain and range. Okay, so we're going to go up here. Where's our boundary line at this time? What's different about this one? What's different about this one compared to the other two? Look at these boundary lines. Right here, x is greater than 0, x is less than 4. What's different about this one? There's 2 of them, right? So guess how many lines there's going to be? 2. Where are they going to be at? Where are those 2 lines going to be? -4 and -1. So we're still going to do the same thing. We just have 4. 1, 2, 3, 4, -4, and -1. Tell me what this actually says. What does it tell you about x? What does this tell you about x? Zoomers, you can answer too. Right, so x is in between them, right? So if x is between, what do you think the graph is going to be? It's going to be in the middle. So we're actually graphing in the middle right here, okay? So x is between, the graph is between. So we're not graphing over here, and we're not graphing over here. We're graphing between -4 and -1, all right? What does this inequality tell you? It's closed. What does this inequality tell you? Open. So this says on the -4 boundary, we're going to close the point. On the -1, we're going to keep it open. Okay. They ask you to plug them in. I'm not going to ask you to plug them in. Here's what I'm going to ask you to do. Go to your y equals. Put in your function, x plus 3 to the second. We're going to go into our table and look for those 2 boundary points. I don't need to plug in. That's what I'm trying to tell you. If you have your calculator, there's no point in you having to do it by hand other than the graphing part. So go to your table and look at -4. It's -4, 1. On the -4 side, the boundary should be. On the -4 side, the boundary should be closed. So -4, 1 is closed. Look at your boundary for -1. Your coordinate is -1, 4, and it should be what on -1? Open. So -1, 1, 2, 3, 4 is open. If it's something as small as this, go ahead and graph everything between. So at -2, it's +1. At -3, it's 0. And then you guys can see that that is your vertex. And then here's your graph. Make it U-shaped. So what we're doing is cutting some of the graph off. That's it. Okay, we're just cutting it off. Look at the next one. What kind of graph is this one? Absolute value. What kind of transformations does this have? What's the +4 do? Not right, but it's on the end, so it's going to be up 4. If it were inside, that would be your right or left. Remember, when we take it out of those parentheses or anything, when we take it away from x, we change the sign, okay? So this one would just be 0. It's fine. What does this negative do? What's the negative in front do to a function? Flips it upside down over which axis? The x-axis, the x-axis. Good. So here's what you guys were doing wrong yesterday. If it's on the front, it's a reflect x. If it's with the x, so if I changed it to like this, if I had it like this, change x, reflect y. Okay, so if the negative is with the x, it's a reflect y. If it's on the front, it's a reflect x. Some of you guys, I already graded your quiz from yesterday. You can go back and fix it, okay? Go back and fix it, because the biggest thing that you guys did, you were getting this pretty well, but the reflections you were not getting, okay? So again, on the front, it's reflect x. Inside with the x or at the x, it's going to reflect y, okay? So on this one, where are my 2 boundary lines? -3. And 5. So we're graphing in between there. Remember that means, and if you guys want to mark that out, that's fine. I don't mind. So that way you can remember, hey, don't graph in there. On this boundary of -3, when I plug it into my calculator and I look at my table, is this one going to be open or closed? Open. Why is it open? Not equal to. What about this one? Is everybody good? All right. Then I'm going to go to my calculator because I'm too lazy to do the work by hand. The least I can do by hand, the better off I'm going to be. To find absolute value, because I know some of you had trouble with this the other day, you go to math, you go over to num, and it's the very first one. So math, num, and hit enter. It'll throw those absolute value ones. Sorry. Our function has an x inside, then get out of it, +4. Okay. I'm going to do it one more time just so you guys have it. A negative, you go to math, over to num, absolute value, you're going to put your x in, and then get out of that, +4. We're going to go to our table. Our table is second and graph. And we're looking for -3 to 5. So I'm going to start with -3. What's my coordinate for -3? -3, 1. Is it open or closed? -3 is open. So -3, +1 is open. And again, I exaggerate it so I can tell that it's open. I want you to exaggerate it for me so I don't think that it's closed. Okay. I'm going to go to 5, +5. And that graph or that coordinate is 5, -1. But that one is closed. So on 5, it should be closed. You want to graph everything between. So we started at -3, -2, 2. negative 1, 3, 0, 4, 1, 3, 2, 2. If you guys see the pattern, you don't have to keep looking at it. And then connect it. Remember, this one should be V-shaped because it's absolutely valid. Zoomers, if you have questions, let me know. Everybody good? All right, we're gonna flip it.
I had a question.
Go ahead.
When I put the absolute value and I went to go to the table, I got an error message.
What error did you get? What did it say?
It said syntax.
Okay, make sure that when you put this negative in, you use the negative and not a minus. Try that, see if that changes it.
It helped, or it
Okay,
did it.
perfect. So that's why I asked the error. Anytime it's a syntax error, that's what you guys have done. You switch the minus and the negative. And that's okay. I get that a lot. Otherwise, I wouldn't know that. All right, so don't feel bad. Everybody else okay? All right, so now I'm actually not going to flip. I'm going to go back and do domain and range. We're having a little bit of trouble with domain and range a couple days ago, so I just want to go refresh it one more time because you're going to have to do domain and range of these as well as piecewise. So we got to be ready for it. Got it? All right, so we're going to talk about domain. Remember, this is domain restriction. So your domain is not going to be negative to positive infinity anymore. Okay, so when we look at our domain, remember that is how far left to how far right. Sometimes it'll have parentheses, sometimes it'll have brackets. Okay, so on this one, what is the leftmost point that we have? So if you need to, use your paper, go all the way across left to right till you get to a point. What's your leftmost point? 0. Is it open or closed? So we put a bracket. Again, you will have to do this on your test. So if you have questions, please ask. We're going to keep going until we see another hole, or what do we see at the bottom right here? An arrow means it goes to infinity. You guys are doing fine typing in infinity, doing the 2, I don't care. What you're doing is perfect when you're typing it in, okay? So don't stress about that. Then we're going to do the range. Remember, your range is always low to high. So our range on this one, we're going to start at the bottom with my little note card. What do I see at the bottom? An arrow that goes to negative infinity. It is never included. Then we go up till we stop. We stop at this closed point at what on the y-axis? 3. Since it's closed, we bracket it. That's your domain range. It's the same thing we've been doing. We just got a shorter graph. Okay. Look at your next one. Domain on this one. We're going to start on the left. And we're going to go across. What happens? What do you see? An arrow means negative infinity. Make sure it's negative because we're going to the left. As we go to the right, we get stopped at this boundary. What is that X boundary? We got it one more time. What was our X boundary? 4. 4. Is it bracket or parentheses? Why is it parentheses? Because I open circle. Very good. All right. Range goes from low to high. What is our low point? 4. Be careful on this one. The 4 is closed. As I go up, I see a hole, but what else do I see on my Post-it? Right here, you see a solid point, right? Remember, they cancel each other out. So we just keep moving. So we ignore it and keep going. What do I see at the top? An arrow, so it goes to infinity. Always a parenthesis on infinity. Guys, if you don't understand, please ask. Yes, it should be -4. Thank you. Sometimes I get to talking and I don't even. Always fix it, always. Guys, if y'all see it, correct me all the time. I don't care, it doesn't bother me. You know, there are things that you do that you know, like you add, subtract wrong, just something stupid. So anytime y'all see it, fix it. Okay. All right, look at this one. Domain, left to right. How far does it go to the left? -4, and that one is closed. It goes all the way to -1, and that one is open. So parentheses. Your range, what's the lowest it goes? It's a solid point, so I'm gonna close it up. We keep going till we get to the top. And the top is at 4, but it is open. Last one, domain and range, and then we'll get to the rest of them. Your domain. We start this way, open or closed? Open at -3. We keep going over, everything's closed until we get to another stopping point at open or closed. So it's a bracket. You're going to do your range. You're going to go from the bottom. Where's the lowest point? Say it again. -1. It's closed. We go up and we see a hole, but if you guys look over here, it fills it in. So we're just going to keep moving on. And what's your highest point? 4. And it is a closed point. You will have these on your test that you have to do domain and range. Domain and range is the worst goal on the test all the time. So if you have questions, go ahead and ask now. Please go ahead and ask now. All right. Here we go. 4 more and then we're done. Okay. So on this one, what's the difference in our domain restriction? What's different about this one? It says does not equal. Does not equal. So it's like an equal with a slash through it. So what this means is don't graph on 1. You can graph everywhere else but 1. Don't graph on 1. You still draw the boundary. But we're going to make an open circle when we get to this boundary. Okay, so it doesn't say don't graph on the left. It doesn't say don't graph on the right. It says just don't graph on that line. That point does not exist. So we're going to plug in our function. All right, look at my calculator. 3 to the x minus 5. I'm going to go to my table. And you know, with exponential, it gets really close to whatever our horizontal asymptote is, but it doesn't go over it. So if you guys look, what's our horizontal asymptote? What's our horizontal asymptote? -5. We don't ever cross. 1, 2, 3, 4, 5. So remember, I did it like this. We can't cross that. And then let me talk to you about this for just a second. On this exponential, what's your transformation? What's your transformation on the exponential graph? What's this tell you? Left, right, up or down? Down what? 5. So everything moves down 5. So if we had a y-intercept of 1, remember they're always a y-intercept of 1, and we move down 5, our y-intercept is actually going to be 4. Okay. You don't have to do that by hand. I'm just giving you an idea of how it works. Okay. What you need is everything except for 1. So what I do is I graph the boundary point to make sure I do it right. We do an open circle at 1, -2. And then we graph everything else. So everything else is a solid point. So 0, -4, which is exactly where I told you that y-intercept would be. We have 2, 4, 2, 1, 2, 3, 4. And that's probably all we're going to get on this graph, which is fine. So instead of having to do all the decimals, remember what I told you? I just go as close as I can. We're going to swoop up. Don't go through that circle. Just leave it open. And then up there as well. Dylan, you need to be here on time or I'm going to start counting you absent. We've already been talking for over 30 minutes. Okay, you have to be here or I'm going to count you absent. What's your domain for this one? So we go from left to right. What's happening on the left? Infinity is always an open or a parenthesis. What happens as I go to the right? We have an open circle on what? 1. So we have to open on 1. But I have more graphs, so how do I keep going? U, where do I pick up at? Right where you left off. Don't change that number. And then how far do I go? Positive infinity. Perfect. Your range, like I talked to you yesterday after our notes, your range on your exponential have been a little bit atrocious. Hopefully they're a little bit better now. But if not, what's the lowest this graph will go? -5, but it will never touch -5. So we put a parenthesis. That number should always be your horizontal asymptote. As we move up, we see an open circle at -2 on the y-axis. It's open, so we keep it open. But there's more graph, so we put our U and we pick up right where we left off. Do not change that number. Then how far up do we go? Forever. Perfect. Positive infinity. Questions like those are the most missed on the test. Okay, so watch those. All right, so this one says does not equal to. This one says it is equal to. So this one said don't graph on 1. So what this one says is only graph on the boundary. Don't graph anywhere else. So our boundary is at 3. If we only graph on the boundary, what is our graph going to look like? Kind of a trick question, but it's not. Just 1 point. Yes, just 1 point. So again, I'm going to use my calculator for that. I shouldn't have to use my calculator for this one, but I'm going to show you just in case you have to put a function in. You should already know it again, but it's okay. So I'm only graphing on 3, so I'm going to look at my calculator. If you notice, all your y's are the same because it tells you that. But 3, -2. Since it's equal to, it's just a closed dot. It's just a closed dot. One of the most missed problems on the test is the domain and range of a closed dot. Domain and range. So here's your domain. This will be on the test. Okay. This is typically on the test. All right. So what's your domain? If this is just a coordinate and it's just 3, -2, remember 3 is your x, 2 is your y. Domain deals with x. What is your x? 3. Is this a closed point or an open point? Closed. So the only value of x you have is 3, and it's closed, so we bracket it. So then what would your range be? -2. And again, a bracket because it's a closed point. All right, so now we're gonna write the function, which we already know how to write the function. But then we're gonna do the domain restriction. Write the function and its restricted domain for the given graph. All right, so what kind of function is this? This one is quadratic. I know because it's U-shaped. It should have a negative in front because it's flipped over. Do we have any arrows on it? No, so it's bound on both sides. I think the easiest part is writing the X statement that we've been looking at, so the boundary part. So it says that the graph is between what two numbers? What are our two boundary lines? -4 and 1. So this is what it says. -4, X is between, sorry, this should be +1. -4 and +1. I'll just take that. I don't want y'all to get confused. The symbols inside are always less than. What you have to decide, is it equal to? We notice that this is a closed point. So that means it has to be equal to. On the 1, it's a closed point. So it also has to be equal to. So that's the easiest part. The other part is remembering how to write your quadratic functions. So here's how it works. Remember, we have y equals a times x plus whatever your vertex is squared plus whatever your vertex is. So that's your vertex, x, and y. So this is a reminder from day 1. I think we did this day 1. Okay, maybe day 2 because it's split. Here's your vertex. Where is your vertex at? What's that coordinate? Say it again. -1, 4. Sorry, I just didn't hear you. This is your vertex x and your vertex y. What happens when we put x inside of parentheses? Remember, when we take it out or put it in, what do we do? Say it again. What happens to our x when we take it out or put it in? When we're trying to find our translations, what do we do with that x coordinate? We change the sign, yeah. So when we put it in, we change. So right now it's a -1. So we make sure that we change it to +1. Remember that we keep the end number. So then the last thing that we're going to do is plug in an XY value. Doesn't matter what point you pick on the graph, as long as it's a closed point. So pick a closed point and then solve for A. So both of these are closed points. I already have them. I could pick this one. It's a closed point. So this is at -3, 0. I'm going to pick that one. I don't like to pick the boundary points because sometimes you'll forget that they're open and you'll try to use an open point and that won't work. Okay. This becomes your X and your Y. We're almost done, guys. Your Y is 0. Your X is -3. And then add 4. That X you will not change. You only change the vertex X. Clean it up. -3 plus 1 is -2. Squared is +4 times A is 4A. So one more time. -3 plus 1 is -2. -2 squared is +4 times A is 4A plus 4. How do I finish solving? Subtract 4. I get -4 equals 4A. We're going to divide by 4. And I get A equals -1. Remember we said we had to have a negative out front for it to be flipped over. So we did good. You just take that -1 and put it where this A is. So our function is Y equals, what was our A? -1. And then rewrite the rest of what you started with right here. X plus 1 squared plus 4. That's your function. So again, the easy part is writing the domain restriction. The hard part is finding the function. Quadratic and exponential are the worst ones. Linear and absolute value make it even easier. They're so easy, okay? So let's look at your next one. I see an arrow on this side, so I know that I don't have a boundary over here, but I see a closed point on this side. So we're not graphing in between, we're graphing on which side? The which side? The left. Everybody go to that. Which inequality represents the left? Less than or greater than? Less than. So x less than. Again, because we're graphed on the left. This is a closed point. So we're going to do equals to. And where is that line graphed? That's it. That's all you do. All right, so absolute value looks like this. How did I know it was an absolute value? It's a V shape. We started just like the quadratic, but this one's easier because I don't have to do a bunch of work on it. Okay. What's your vertex point? Right. 1, -3. What happens when I put this 1 into the equation? What do I have to do this 1 when I put it in the equation? Change the sign. Always change that x. Leave the end the same. For linear or absolute value, all you have to do now is find the slope. Find the slope. So you can do rise over run. You can do it right here. This is the easiest one to do it on. What's your rise and your run? 1 and 1. If you had to do it on the other side, you could do it as well, but realize that it's still going to be a positive number because the graph is pointed up. Okay, don't let that confuse you. So our slope is 1. We have x minus 1 and a -3. If you're looking at this on a multiple choice, it's just going to have f of x equals. It will not have the 1 in front. It'll just have x minus 1 minus 3. Okay, you don't have to plug in extra points for that one. All right, real quick, and I'll finish. Real quick, and I'll finish. I want to know the domain and range for these two. It didn't ask, but I want to know. Okay, what's the domain for this first one? How far to the left do we go? Is it open or closed? Closed. If we look all the way to the right, there's no open circles, and then we have to stop on the right at what? 1, and it is closed as well. There's your domain. Range. How low does it go? Yep, and it is closed. As we go up, there are no holes, and I stop at a height of what? 4, also closed. Very good. Last one, domain and range. I'm gonna put it at the bottom, so I can't move my paper over any. From the left, what do you see on the left? Negative infinity, an arrow, negative infinity. As we move to the right, I don't see any open points, and then I stop at this boundary, and what's that boundary? Is it open or closed? The point was closed, so it's a bracket. All right, range at the bottom. What's the lowest it goes? -3. It is a closed point, so we're going to bracket it. How high does it go? Infinity. Very good. Again, you'll have to do domain and range on your test. All right. Zoomers, stay on. We're going to kind of do the same thing on Monday. I'm going to stop sharing, stop recording. Kind of do the same thing on